Good morning, students. Till yesterday, we have discussed the classification of the solids into the two parts. The one was the amorphous solid, and the second was the crystalline solid. And yesterday, I told you that we will discuss the crystalline solid in the next lecture. So today, we are starting the next part, that is the crystalline solid. You know that crystalline solids are those solids in which the particles arrangement will be fixed. Is it fine? And they will give rise to the particular type of the geometry, and this geometry will be repeated for a long range of the order. Is it fine? Now today we will classify this crystalline solid into the four parts. The first one is called as a molecular crystalline solid. The second one is called as ionic crystalline solid. Third one is a metallic crystalline solid, and the fourth one is a covalent or the network crystalline solids. Okay, so independently there are four categories. Now we'll describe all those four categories independently. Now the first thing is your molecular crystalline solid. What is the meaning of the molecular? These crystals are available in the form of the molecules. These molecules will be very small. Is it fine? Clear? So you will see that these molecular crystalline solids are there, which are of how many types? Three types. The first one is a polar molecular solid. Non-polar molecular solids, and second one will be the polar molecular solid, and the third one will be the hydrogen bonded molecular solid. So ultimately, this whole classification was there. Is it fine? The second one, like ionic also there, metallic also there, and this is the whole classification is there. This is based upon these 4 points. Actually, the type of the force of interaction present among the particles, on the basis of that interaction, there are 4 kind of the main types of the crystalline solid. The first one will be they can have the van der Waals force. Second one, they can have the ionic bond. They can have the covalent bond. Even the metallic bond is also there. So these kind of the forces, or the force of attraction, or the bond formations are there, and on the basis of them, the classification is done. Is it fine? So let's discuss the first thing. So I told you molecular crystalline solid. Okay, so it will be further subdivided to form what? To give that non-polar molecular crystalline solid. What is the meaning of the non-polar? Here in this part you will see that when two or more than two similar type of the atoms are combining and forming the covalent bond. Are you getting me? When two or more than two smaller molecules, I'm talking of the smaller molecules, maximum 2 or 3 atoms can be present in one molecule. I'm talking about that only. Is it fine? So they all are having the specific type of the bond, then that will be the covalent bond. And you know that covalent bond will be different kind. See, normal covalent bond and the shifting of the this thing, electron pair towards the highly electronegative, that will be forming the polar character. Is it fine? So first discuss the non-polar molecular solid, in which what happened? Two or more than two similar type of the atoms forming the molecules, and the sharing of electron is taking place exactly at the center between these two atoms. Is it fine? Sometimes they can available in the free form also. You can see that helium, argon, hydrogen, chlorine and iodine, when they are compressed, then they will be converted into the liquid form, or further compression or low temperature, they will be converted into the solid form. So these solids will be having crystal structure, and these solids are also known as a non-polar molecular solids. Understood this thing? Now you will see that in these particles you will see the London force is present. London force in the 11th standard you have seen, that is also known as a dispersion force. For some instance, for some small time period, that electrons will be shifted towards another atom, and they will be attracted by the another nucleus of the another atoms, and there will be a shifting of the electron density on the other side. Is it fine? This is for some time period. Okay, this is called London force or the dispersion force. So on the basis of dispersion force, this is there, and they are bad conductor heat and electricity, because no free electrons are present in that. Clear? And they are soluble in the some can be soluble in the water, or some may not be soluble, and they can be soluble in the different solvents. Is it fine? So this was the first part. Now coming to the second one, that is a polar molecular solid, polar molecular crystalline solid, we can say in that other part. What is the meaning of the polar molecular crystalline solid? You'll see that when two or more than two atoms of the different electronegativities are combining together by covalent bond formation, then what happens? The sharing of electrons will be towards the more electronegative element. The sharing of electrons will be towards the more electronegative element. Understood, students? In that condition, what happened? There is a generation of the dipole, right? And the polar bonds are produced in that. Is it fine? So you have seen that polar bond formation or polar characters in the 11th standard. So these are forming polar molecules, right? So they can be of SO2, NO2, NS3, etc. Such type of the that the compounds are there which are forming that polar molecular solid. So, what about that conductivity? They are also good conductors. Sorry, they are also bad conductor of heat and electricity. Is it fine? Because no free electrons or the free ions are present in that. Is it clear? Now come to the third one. You will see that hydrogen bonded molecular crystalline solid. In that, a molecule is produced and the molecules will be attracted by the another molecules by the formation of the hydrogen bond. Is it clear, student? So in that case, you will see that water will be having the hydrogen bond. In case of the liquid form of the water, hydrogen bond will be present, but in the solid form, hydrogen bond will be much stronger. Is it fine? So because of that hydrogen bond, this is having the fixed geometry and fixed crystalline structure. Is it fine? So that will be your hydrogen bonded molecular crystalline solid. So what about the conductivity? This is also bad conductor of heat and electricity. This is also the bad conductor of heat and electricity. I hope you all understood this part. So these are the three kinds of the molecular crystalline solid in which the covalent bond is present. Okay, and in the first one I told you that the London force is present. So London force is a kind of van der Waals force. Okay, now come to the second one. That is your ionic crystalline solid. In that you have seen the ionic bond formation. Is it clear? So in that, one cation and one anion species will be there. Is it clear, students? So here in this part, these two ions like cations and anions will be attracted by some specific type of the force of attraction, and that is called as a Coulombic force of attraction, or that is also known as your electrostatic force of attraction. Understood? And Coulombic force of attraction, that is F is equal to K Q1 Q2 upon R square. Q1 Q2 is the magnitude of the charge on the two opposite ions. Is it fine? And R square is the distance between the two charges, right? And K was the constant, and K's value was equal to 1. So I have not taken that one value. So directly the formula will be F is equal to Q1 Q2 upon R square. So this is the Coulombic force. Okay. So by this force, the ions will be connected with each other. They are joined with each other, and they are forming a particular type of the geometry, and they form that particular crystal. That's why these are called as an ionic solids. Understood? Now, what about the conductivity? Ionic solids are bad conductor of electricity in their native form. When they are in the solid form, they will not conduct heat and electricity. Is it fine? But when they are in the soluble form, once they are dissolved in the water, or they are heated up till they get come in the molten state, so then ions will become free. So if the free ions are present in the particular material, or in the solvent form, or in the free form, then you will see that the electricity will be conducted, and they are that brittle in the nature, and they are harder material. They are hard but brittle. Is it fine, students? So this is the classification of the ionic solids. Understood? Now come to the third one, that is a metallic solid. This is a kind of crystalline solid in which you will see that all atoms will be identical. Okay, because this is metallic atoms are present, and if all atoms are similar kind, then how these are intact? Understood? How they are closer to each other, and they are forming the particular type of the geometry. What is the reason behind it? So only one answer for all these questions is these all atoms which are present in a particular metal which is solid in the nature, these are having the free electrons in the outermost orbitals. Is it fine? So these free electrons can revolve around one atom, and in the second case you will see that while revolving they can enter in the orbital of the another atom, and another atom's electrons will be shifted by just passing from all the atoms. The electrons can come back again on the first atom. So in that way you will see that electrons keep on revolving around each and every atom. So due to which what happened, a force of attraction is generated, and that is called metallic force of attraction, or a bond is called metallic bond. And this metallic bond is responsible for keeping all these atoms closer to each other, and giving out of the certain type of the geometry. Is it clear? And this geometry will be there in the crystals, and that's why it is called as a metallic crystalline solid. Now these free electrons are responsible for many of the properties of the metals, like metals are malleable, metals are good control heat and electricity. Is it fine? And metals can give the particular type of the color also. Is it clear? So these are the certain characteristics of the metal, and these are the metallic properties. Understood, students? Okay. Now, coming to the last one, that is called as a covalent or the network crystalline solid. Actually, here it is a covalent. This is also covalent bond and that is a covalent bond. But this is for the small molecules, very small molecules. But this is for the giant molecule and it is also known as a network solid. In that, what you will see, like covalent solid can be of three kinds, and I think you will get the idea by just listening the name of the examples of this one. The one is a diamond, second is a graphite, and the second is a third is a fullerene. So we discuss about the diamond and graphite, especially in that part. So in case of the diamond, you will see that the network of the carbon is present in the whole crystalline solid, and all carbon atoms are connected with each other by a bond, and that is called as a covalent bond. Understood? All these covalent bonds are there in each and every carbon atom, and they form the giant molecule. And because of this covalent bond and because of that covalent network part, the diamond is the hardest naturally occurring substance in the nature. Is it fine? And it is a bad kind of heat and electricity because there is no free electrons. One carbon atom is surrounded by the four carbon atoms, or four valencies are used, and this is giving the tetrahedral structure, and this tetrahedral structure will be repeated again and again, and it forms a particular geometry. This is a diamond. Now coming to the graphite, you know that graphite will be having the hexagonal rings. Okay, so this is one hexagonal ring. Okay, and that is another hexagonal ring. So when hexagonal rings are connected with each other, fine, so you will see that one carbon atom will be surrounded by the three carbon atoms. Suppose if you talk about this carbon atom, the 1, 2, 3. So only three carbon atoms are surrounding them. Then one electron will be free, and this electron can jump from this layer to this layer, this layer to this layer. So there is a weak van der Waals force is generated between these two layers, and this van der Waals force is responsible for converting this graphite into the dry lubricant. Why is it so? Because whenever you apply the force on the graphite, the one layer is sliding over the another layer, and due to this property, what happens? It can be used as a dry lubricant. And one more important property of the graphite is it has the free electrons because of the free bond, and this free electrons can jump from one layer to the another layer, and in that way it will conduct the electricity. So this is also a good conductor of electricity. The fullerene is there, the third one, that is also a giant molecule. Is it clear? So this can be converted into the carbon nanotube. So you will discuss in the higher classes, or maybe in the nanotechnology if you discuss. Is it fine? So these are the four general classification of the crystalline solid. Okay, now the another topic. So the part is the crystal lattice and the unit cells beta. I have made I have just made some arrangement of the particles. Here you will see that all the particles are coming in the one line, and here one line, two line, three line, one line, two line, and again similar to the first, and then second similar to the second. So what are these? These are actually the arrangement of the particles, and these particles are called as lattice points. So what is the lattice? Lattice means what? See that it's an arrangement of the particles in the space. Understood this thing? It is the arrangement of the particles in the space, and after the arrangement of the particles, you take out one smallest unit. Is it fine? And after that, what happens? If you break it, then the particles will get separated from each other. Then smallest unit is called as an unit cell. So here I am showing you that how the unit cells can be made from that. So if the arrangement of particles is like this, then you can see that this is a kind of square. And when such type of the squares are combined, then it forms a cubic. Is it fine? Here you will see that it is forming 1, 2, 3, 4, 5 hexagon type of this. Is it clear? So from these arrangement of the particles, we can make the various type of the geometries. Is it clear? And from these geometry, we can take out the unit cells, and these unit cells will be having the different shapes. So here you will see that the first one, side A, both are equal, but the angle is 60 degree. Understood? So this can be considered as a parallelogram. Here it can be a rectangular shape. A and B both are different, but angle is 90 degree. So this is rectangle. Here it can be cube. Sorry, it can be square. Is it fine? So both AA are similar and 90 degree angle. So this is the square type. And this can be a kind of rhombus, in which what happened, the third angle will be different, and A and B will also be different. Is it clear, students? So these are the shape of the different shape of the unit cell. And this is the 2D diagram of these things. So I tried to take out the unit cell. This is the simplest unit cell which I have taken, and the particles are present at the corners only. You will see that particles are present only at the corners of this unit cell. This is the simplest, and after that, if I break it, what happens? It can be the particles will get separated. Now, if you need to find out the dimensions, if you take one point, So I have taken 1 point. So there are 3 layers, 3 lines, 1, 2, 3, and each are considered as A, B, and C line. Okay, the angle between A and B is alpha, angle between B and C is beta, and angle between A and C is C. So you will see that how will you find it out? Suppose if A line is equal to B line is equal to C line, that means all the 3 lines are equal in that, and alpha, beta, and gamma, all the 3 angles are equal, and that is equal to the 90 degree. Then what could be the unit cell structure? This is called as a cubic unit cell structure. Understood this thing? In that way we can make the various type of the unit cells. Is it clear? Monoclinic, and then rhombohedral, and triclinic, many are there. Is it clear? So you will see that in the textbook. You just see in the textbook there is a table in which everything is written. Is it fine? So write down that table, okay, and find out the different type of the lattice structures and the unit cell. Okay, that's all for today. Have a nice day, beta.